Hello guys, welcome back to another video of the series where we are solving computer vision problems from the dataset that has been provided by torchvision. So torchvision.datasets provides several datasets, but the dataset that we're using is FashionMNIST dataset. So FashionMNIST dataset contains 70,000 image samples of 28 by 28 pixels grayscale images. So in FashionMNIST dataset, there are 60,000 training datasets and 10,000 testing datasets. So in this video, what we'll be doing is we'll be importing FashionMNIST dataset in our Google Colab notebook, and we'll be visualizing those datasets. So let us import the dataset in our Google Colab notebook. So in my Google Colab, I have already connected to the runtime. So let us start by importing our dataset. But before importing dataset, we need to import torchvision, because from torchvision.datasets, we'll be importing the dataset. So let us import torchvision. We will also need to import dataset from torchvision. So from torchvision import dataset, and we will import transform from torchvision. So from torchvision import transform. Also, we need to import toTensor method from torchvision.transform. So from torchvision.transforms import toTensor. So this is transforms. So toTensor is a method that is used to convert our numpy.nd array to tensor format. So initially, when we import our dataset, it will be in the format of numpy.nd array, and we need to convert to tensor. So toTensor method helps to convert nd array to numpy tensor. So after importing our necessary modules, let us import our dataset. So let us import our training dataset first. So datasets.fashionMNIST. So we want to download the data in root equals to data, which means we will be downloading in data directory. We want to download the train dataset first, so train equals to true, and we need to transform the dataset from numpy nd array to tensor. So transform equals to transforms dot toTensor. Also, we need to download the dataset, so we need to set download parameter as true. And we do not need to transform the target, so we will set target transform as none. So in similar way, we want to import our testing data. So test data equals to datasets.fashionMNIST. Again, we want to download in data directory. We do not want to download train data, so we put train parameter as false. When we put train parameter as false, it will download test dataset. Again, we need to transform our dataset from nd array to tensor. So transforms dot toTensor. Download equals to true, and then we will not transform our target. So target transform equals to none. Let us run our cell, and since this cell has run, our data must have been downloaded. So let us view the dataset. So let us view the first sample of our train dataset. So train data 0. So our train data will have image, which is in the form of tensor, and then it will have a label. Let us print image and label, and let's visualize it. So we can see that the image is a tensor. It's a 3-dimensional data, and then label is something like this. So this is an index. So let us view what are the classes in the dataset. So class names equals to train data dot, there are various properties. So we will access classes properties from train data. So we can print it out to see what are the classes. So we can see that train data contains several class names: t-shirt, trouser, pullover, dress, coat, and much more. So there are 10 classes in our train data. Now let us also view the index of these classes. Class to index, IDX, train data dot class to index is a property which converts the class names into index. So let us print the class to idx, and okay, we can see that every class names has been associated with the index. So t-shirt top has been assigned with index 0, trouser is 1, pullover is 2, and so on. So let us check the shape of our image tensor. So image.shape, and of course label is a scalar, so we don't need to check the shape, but our image is 3-dimensional. The first dimension represents color channel, second dimension represents height, and third dimension represents width. So it's 28 by 28, and then one is that it has only one color channel. So we can see that our image is a tensor. So how does this image look like? Currently it's just numbers in the page. So let us visualize this tensor using Matplotlib. So let us import matplotlib.pyplot as plt, and let us visualize our image tensor. So plt.imshow, and we want to visualize our image, but plt.imshow method expects 4-dimensional image, but currently we only have 3 dimension in our image variable. So to convert into 4 dimensions, we need to add 1 extra dimension, and we can do that by using squeeze method. It needs 4 dimension because the first dimension represents batch size, second dimension represents color channels, and third and fourth represent height and width. So with this, we are adding an extra dimension that represents the batch size, and also let's put a title to our image, plt.title, and we want to index through class names, and the label will give us the index. So let us run the cell and visualize our image. Okay, we can see that our first sample of our training data, which we have stored in image variable, is a ankle boot, and the image looks something like this. So again, let us view another data. So image label, let us view the 69th index of our training data, 69, and let us plot it using plt.imshow image.squeeze, because we will have to add extra dimension, and let us this time add cmap equals to gray because we want to view grayscale images, and plt.title will be, we want to index through class names and pass in the index which is label. So the 69th sample of our training data is a trouser, and we can see this time it's grayscale image. So let us again visualize different images from our training data. This time what we'll do is we'll look through our training data, and let's visualize something like 16 images. So let us do torch.manual seed because we want to add reproducibility, 42. Okay, you see a yellow squiggly line because we haven't imported torch. So first of all, let us import torch in the cell, and now let us visualize our data by plotting 16 images from our trained data. So torch.manual seed 42 is a good number. So plt.figure, so let us specify the figure size as 9 by 9. Okay, so let's do for I in range. Let's say we want 16 images, so we will put 1 to 17, and then let us create a subplot. We want 4 images in one row, and we want 4 columns, and then we want I, which is the index, which will be 1, 2, 3, 4 up to 16. So plt.imshow train data, and we will need I, which will be different images, and we want 0. 0 is that it will give us the image because 0 index contains image and first index will contain label. So we also want to squeeze because we want to add an extra dimension, and CMap will be gray because we want in the gray scale. Now similarly, let us put title to our image. So to display the title, we want to go through our class names and we want to pass the index in this class names. So first, we want to put 1 in the index because for 0 is image and then first is the label. So we also want to turn off the axis for more good visibility. So let us run this here, and this should provide okay in data. So this was all for this video. In the next video, what we'll do is we'll prepare the data loader because we want to pass batch of images through our neural network. So see you in the next video.